All right, let's dive right in. Today, we're going to talk about something that's quietly running the entire digital world. We're going to see how we can take the complete chaos of raw data and bring it into order, all through a process called normalization.
So, to get us started, let me ask you a question. What on earth do messy closets and bad databases have in common? I know it sounds a little random, but trust me, the answer is key to understanding why we even need to organize data in the first place.
Okay, have a look at this table. This is what we'd call unnormalized data. Just look at that students column. We've got multiple names all just jammed into one cell. And what happens if Santos advises another subject? Well, we'd have to type their name all over again. It's basically the digital version of just throwing all your clothes in a giant pile and hoping for the best.
And that brings us to the answer. They're both a total mess of redundancy and chaos. And in the world of databases, that chaos causes some really nasty side effects we call data anomalies. What that really means is that doing simple stuff, like updating a name or adding a new student, suddenly becomes a huge headache and super easy to mess up.
But the good news is there is a cure for all this data chaos. And that cure is called normalization. You can think of it like a professional organizer for your data. It's the hero that's going to come in and clean up this whole mess.
So what is normalization exactly? Well, here's the official definition. It's a process that assigns attributes to entities. Okay, let's break that down. Entities are just the main things we're tracking, like students or advisors. And attributes are just their details, like a name or an ID. Normalization just organizes everything so that we can get rid of all that repetition and make sure every single piece of information has one and only one logical home.
And this whole process has a very clear mission. The objectives are pretty straightforward. First, every table should be about one single thing. Every little cell should hold just one single value. And super importantly, everything has to depend on a primary key, which is really just a unique identifier for each row, like a student ID number. If we follow these rules, we get to wave goodbye to those frustrating data anomalies.
So, where do we start? Let's take that first step and see how we can start building a much better, more orderly structure. This first stage has a name. It's called the first normal form.
And here it is. This is our data in what we call first normal form, or 1NF. See what we did? We got rid of those repeating groups by giving each student their own row. Now every cell has exactly one value. This is a massive improvement, but we're not done yet. You can still see all that repetition, right? The names A. Santos and math are typed out over and over again.
So, to deal with that leftover redundancy, we've got to refine our structure even more. And the way we do that is by breaking this one big table into several smaller, much more focused ones.
So first up, we make a table just for advisors. That's it. Each advisor gets their own unique ID, and their name is stored only one time. This is huge, because now if an advisor's name changes, we only have to update it in this one spot. You know when you change your email on a website once and it updates everywhere? This is exactly how that works. It's simple and it's so much more efficient.
Next, we do the exact same thing for the subjects. The subject name and its code, they get their own dedicated table. And again, that information is only stored once, making everything clean and so much easier to manage.
And you guessed it, the students get their own table too. Each student has their unique number and their name. We've now successfully taken each of our core things, our entities, and given each one its own separate, tidy home. Okay, so you're probably wondering, how does this all connect now? Well, this is the magic right here. We create what's called a linking table. You'll notice this table doesn't actually store any names. It only uses the unique IDs from our other tables to show how they're all related. It tells us that advisor 001 teaches subject MAT1 to student 018. That's it. And by doing this, we've now reached what's called the third normal form, or 3NF. So we just did a whole lot of work, right? We broke everything down, we reorganized it, but why? Why does any of this really matter? What's the big payoff here?
Well, this slide pretty much says it all. We started with a system that was full of errors and repetition. It was just plain inefficient. But after normalization, we have data integrity, we have way less redundancy, and we have a system that is efficient and can easily grow. This clean, organized structure is the invisible backbone of almost every single reliable app you use, from Amazon to your online bank.
Now you might be asking yourself, okay, how far does this go? Do we just keep breaking tables down forever? Well, here's a fantastic rule of thumb.
Even though there are higher levels, the third normal form, the 3NF we just got to, is considered the gold standard for most real-world applications. It really hits that sweet spot between being super organized and still being fast and performant.
So let's just end with this thought. Every app, every website, literally everything you do online runs on unimaginable amounts of data. So could it be that the real unsung hero of our entire digital world isn't some fancy new AI algorithm, but something as simple and as elegant as a set of clean, well-organized, normalized tables? Something to think about. Thanks for tuning in to this explainer.